So in previous classes, to find out the resultant of two coplanar forces, we applied a parallelogram law of forces. But when more than two forces act at a point, then to find out the value of the resultant, then we are going for another method, that is method of resolution of forces. So up to now we have seen when two forces are meeting at a point, or when two concurrent forces are meeting at a point. For those problems we applied parallelogram law. But whenever more number of forces act at a point, more than two forces act at a point, then using method of resolution of forces, we are going to find out the resultant, value of the resultant, or magnitude of the resultant, and direction of the resultant. So here our topic is when more than two forces act at a point, when more than two forces act at a point, then what is the magnitude of the resultant? Magnitude of resultant. What is the magnitude of the resultant, and direction of the resultant? That we have to find out. To find out this, here we are going a method called method of resolution of forces. Or rectangular components method, or you can say rectangular components method. So according to this method, all the forces acting at a point are resolved into horizontal and vertical components, and then algebraic sum of all those horizontal and vertical components can be calculated separately using the algebraic sum of all the horizontal and vertical components. We are going to find out the value of the resultant. So with one simple example we can understand this method. So according to this method, first we have to resolve all the forces which are acting at a point into horizontal and vertical components. So first here we are considering one force. For example, one force is acting like this, F1. So we have to resolve this force into horizontal and vertical component, and another force, for example, some F2. F2 is acting at a point. We have to resolve this force into horizontal and vertical components, and another force F3, because here we are considering more than two forces. So in parallelogram law of forces, there we considered only two forces, but when more than two forces acts at a point, so these are concurrent forces because all the forces are acting at a point, or they are intersecting at a point. So here we are considering more than two forces. So here we are considering four forces, they are meeting at a point. So according to method of resolution of forces, first we have to resolve all these forces into horizontal and vertical components. So for F1, if you consider this is F1, so it is making some angle with the horizontal. So that angle here we are considering some theta1. So horizontal means this horizontal line we are taking it as x-axis, and a vertical line here we are drawing, that is y-axis. So we have to resolve this force into horizontal component and vertical component. So for F1 force, what is the horizontal component? What is the horizontal component of this force? So we can resolve this force into two components, that is, one is horizontal component and another one is vertical component. So the component which is acting along horizontal is called horizontal component, or the component which is acting along this horizontal axis is called horizontal component. The component which is acting along vertical, or the component which is acting along vertical y-axis is called vertical component. So from this figure, the horizontal component, so this horizontal component is, so what is the value of this horizontal component? So here we can draw like this. So this horizontal component, vertical component, so parallel can draw here also. So here we are forming a right angle triangle. So here we are forming a right angle triangle. From this right angle triangle, cos theta 1 equal to onset. So this is onset, so we don't know that value. So here we are assuming some x by hypotenuse. Hypotenuse is this one. So this is force F1. So x equal to F1 cos theta 1. So this is x and this is y. So here x is horizontal component. That means F1 cos theta 1. So for force F1, horizontal component is F1 cos theta 1. So vertical component, here we are assuming y. So sin theta 1 equal to opposite side. So this is theta 1, sin theta 1 equal to opposite side is y. So this is F1. So sin theta 1 equal to opposite side by hypotenuse. Hypotenuse is F1. So y equal to F1 sin theta 1. So this is vertical component. So the value of vertical component is f1 sin theta 1. So for a force f1, we are getting two components. Horizontal component is f1 cos theta 1, vertical component is f1 sin theta 1. So for every force, it may have two components. So those two components are horizontal component, vertical component. So these two components are positive because f1 cos theta 1. So this f1 cos theta 1 acts towards positive x-axis. So it is a positive value. And f1 sin theta 1. So this f1 sin theta 1 acts in upward direction or in positive y-axis. That's why f1 sin theta 1 is also positive. So this is positive and this one is also positive. So here we resolved the force component. We resolved the force F1 into two components. So F1 cos theta 1 and F1 sin theta 1. Similarly, we can resolve the force F2 into two components. Similarly, force F3 we can resolve it two components, horizontal and vertical. Similarly, F4 also you can resolve into two components. So for each force you are getting horizontal components and vertical components. So using those horizontal components and vertical components, we are going to find out the resultant value. So that's why here, so this is x-axis, this one is y-axis. So F1 is making an angle theta 1 with x-axis. Here we are assuming. So here F2 force is making an angle theta 2 with x-axis, and F3 is making an angle theta 3 with x-axis, but this is positive and this is negative x. Upward direction positive y-axis, negative direction it is -1. So F4 is making an angle theta 4 is the x-axis. So here we are assuming all these forces are making angles theta 1, theta 2, theta 3, theta 4 is the x-axis. So horizontal component for F2. Horizontal component of F2 will become F2 cos theta 2, and vertical component of F2 will become F2 sin theta 2. If one component becomes cos value, then the remaining value become sin value. Here F2 is, or F1, F3, F4, all these are making angle with the horizontal. So horizontal component values, you are going to get cos values, and vertical component values you are going to get sin values. So when you resolve F2, then you will get, so components of F2, horizontal component will become F2 cos theta 2, but this F2 cos theta 2, so this F2 cos theta 2 acts in negative x direction. So F2 cos theta 2 acts in negative x direction, so the value is negative here. So F2 cos theta 2 value is negative. So vertical component of F2 is f2 sin theta 2. So f2 sin theta 2. So vertical component. So this one is f2 cos theta 2. This one is f2 sin theta 2. So f2 cos theta 2 is negative, but f2 sin theta 2 acts in positive y direction. So this value is positive. Similarly, components of f3. Components of f3. So this is f3. Horizontal component is f3 cos theta 3. Vertical component is f3 sin theta 3. So here f3 cos theta 3. f3 cos theta 3 acts in negative x direction. So this is negative value. f3 sin theta 3 acts in downward direction, that means negative y direction. So this value also negative. Similarly, components of f4. So f4 is like this. So it is going to have f4 cos theta 4 acts in positive x direction, and vertical component f4 sin theta 4. So this value is positive because it acts in positive x direction. f4 sin theta 4 is negative, so vertical component is acts in downward direction. So for every force we got two components, horizontal and vertical components. So now we are going to write here all the horizontal components and vertical components. So according to this method, first we have to split or resolve the force into horizontal and vertical components, and then algebraic summation of horizontal and vertical components is done separately. So horizontal summation of all horizontal components, that means sigma h. So algebraic sum of all the horizontal components will be equal to, so for f1 force we have horizontal component f1 cos theta 1, it is positive value. For component f2 we have horizontal component, that is f2 cos theta 2, it acts in negative x direction, so minus value, so f2 cos theta 2. For component f3 we have horizontal component, that horizontal acts in negative direction, that is f3 cos theta 3. For component f4, horizontal component is f4 cos theta 4, it acts in positive x direction, so it is positive value, so f4 cos theta 4. Similarly, summation of all the vertical components sigma v equal to, so horizontal vertical component of force f1 is f1 sin theta 1, so this value is positive, f1 sin theta 1. So for component f2 we got f2 sin theta 2, it is positive value, so f2 sin theta 2. For component f3, vertical component is negative value, minus f3 sin theta 3. For component f4, negative value, minus f4 sin theta 4. So sigma h and sigma v. So this is sigma h, summation of all the horizontal components, and sigma v, summation of all vertical components. The resultant of all the horizontal components and all the vertical components is here. It is R. So we have to find out this R. So R equaled, if this is sigma v, so this is also sigma v. So this is sigma h. So right angle triangle. So R is hypotenuse. So R square equal to sigma h square plus sigma v square. That means R equal to under root of sigma h square plus sigma v square. So the magnitude of the resultant equal to under root of summation of all the horizontal components square plus summation of all the vertical component whole square. So direction means theta. So here it is, here we are assuming this value is theta. So from this tan theta equal to, from this right angle triangle tan theta equal to opposite side by anside. So sigma v by sigma h. So theta equal to tan inverse of sigma v by sigma h. So when more than two forces act at a point, in that condition you can calculate magnitude of the resultant using this method of resolution of forces. So with one example problem we can easily understand this method. So in this problem, so we have to find out the resultant of all these four forces. So 30 Newton force, it is making an angle 30 degrees with the horizontal or with the x-axis, and another one is, here it is 20 Newton. This 20 Newton also it is making an angle 60 degrees with the horizontal, and this 40 Newton, it is making an angle 30 degrees with the horizontal. But here 50 Newton, this 50 Newton, it has been given that it is directly a vertical force, 50 Newton. It is a directly vertical force, so it is not going to have any horizontal component. So it has only vertical component, so that vertical component is 50 only. Or you can say it is making, so it is directly perpendicular to the horizontal. So 50 Newton so it is making 90 degrees with the horizontal. So what is the value of what is the horizontal component of this 50 Newton? So 50 cos 90. So cos 90 means 0. 0 into 50, 0. That means no horizontal components. So whatever the vertical force it has been given, that vertical force doesn't have horizontal component, only it has a vertical component. That vertical component is 50 Newton only. The vertical component means 50 sin theta. Sin theta means sin 90. Sin 90 means 1. So 50 Newton. So this 50 Newton force, it is a directly vertical force. So it doesn't have any horizontal component. It has only one component, that is vertical component. So vertical component of value is vertical force, 50 Newton only. So here 30 Newton is making an angle 30 degrees with the horizontal. For example, in the problem, if it will be given like this, so 30 Newton. So 30 Newton force is parallel to the horizontal axis or parallel to the horizontal. That means it is making 0 degree angle with the horizontal. So at that time, what will happen to the vertical component? Vertical component will become 0. So it is directly horizontal force. So it has only horizontal component. That horizontal component value will be equal to 30 Newton only. You can say horizontal component equal to, so it is horizontal means theta is 0 degrees. So then what happens? 30 cos 0 means 30. Vertical component equal to 30 sin 0. Sin 0 means 0. So vertical component, so it is not going to have any vertical component. So if in the problem, if 30 Newton force, if it will be given like this, if it will be given the directly horizontal force, then the values will become like this. But here 30 Newton force is making an angle 30 degrees with the horizontal. So it is going to have horizontal component and a vertical component. So here we are going to write horizontal components and vertical components first. For 30 Newton force, we have two components, horizontal component and vertical component. So horizontal component is 30 cos 30. Vertical component is 30 sin 30. So if one value is cos, then another component will become sin. For 50 Newton force, horizontal component is 0. So we have already discussed here. 50 Newton force is directly a vertical force, so it is not going to have any horizontal components. So it is 0. So it has only vertical component. So that vertical component is 50 Newton. For 40 Newton. So 40 horizontal component is 40 cos 30. 40 cos 30. So here 40 Newton. So horizontal component and vertical component. So this horizontal component is 40 cos 30 and it acts in negative x direction. So this value is negative. Vertical component will become 40 sin 30. So this vertical component is 40 sin 30 and it acts in downward direction. That means negative y-axis. So that's why it is negative. So one more force is there, 20 Newton. For 20 Newton, so 20 Newton is like this. So horizontal component is here. So horizontal component is making an angle 60 degrees. So horizontal component is 20 cos 60. It is acts in positive x direction, so this value is positive. Vertical component is 20 sin 60. It acts in downward direction, so it is negative value. So horizontal component is 20 cos 60 positive value. Vertical component is 20 sin 60 negative value. So summation of all the horizontal components sigma h equal to horizontal components. First 30 cos 30. For 50 Newton horizontal component is 0. For 40 Newton horizontal component is 40 cos 30 and it is negative value. So minus 40 cos 30. For 20 Newton horizontal component is 20 cos 60. Sigma V summation of vertical components. So for 30 Newton vertical component is 30 sin 30 and it is positive value. For 50 Newton vertical component is 50. For 40 Newton vertical component is 40 sin 30 and it is negative value. So that's why minus 40 sin 30. For 20 Newton component is 20. So it is negative value. So minus 20 sin 60 acts downward. So that's why negative value minus 20 sin 60. So if you calculate 30 cos 30 on the value, you will get so 1.34 Newton. Summation of V, you will get 27.68 Newton. So resultant R will be equal to under root of sigma h square plus sigma v square. That means 1.34 whole square plus 27.68 whole square. So R will be equal to 27.71 Newton. So in calculator, if you calculate, then you will get this also. So this is the magnitude of the resultant and the direction. Theta direction will be equal to tan inverse of. So here, if you consider this sigma h and this is sigma v, resultant is R. So this is theta. Tan inverse of sigma v by sigma h. Tan inverse of 27.68 by 1.34 equal to 87.2 degrees. So in this way, using method of resolution of forces, you can split every force into horizontal and vertical components. After that, using algebraic sum of all the horizontal components and vertical components, you can calculate magnitude of the resultant. So we are going to do more number of problems in further classes on this method of resolution.